Hello. Brr, this video is real hard. It's about linearization. Oh, it's crazy. No, it's point slope form. This is for babies. For babies. So we know point slope form. One thing that calculus likes to do is give weird names to stuff that we already know. So point slope form, look, take a look. This is linearization. We have a slope, we have an x minus some value, and then we've got the y1 on the other side. It's just a linearization. That's point slope form. That's all it is. Now, why might we care about this? I pulled up the thing where I've got my original function here in black, and then I've got my slope of my tangent line. The thing is, let me get rid of this for a second. Even though that's a curve, if I get real close to it, I'm talking like real close, we can see how that's really, even though as I zoomed out, it was curvy, it was pretty much a straight line. So if I use my tangent line, even though as I zoom out and I get farther away, it becomes inaccurate. When it's really close, my tangent line matches up with what's going on with this black line. So while my original function might be really complicated, the slope of a tangent line is a straight line, and I can get estimates for different values using this linearization. So find the linearization of f of x at x equals a. So we need to figure out, first of all, what is the derivative of f? And the place that we would really like to find that is at a. So f prime of a, well, I would write an a, it's at 2. Okay, so that is going to be 3 times 2 squared minus 2 times, just time minus 2. Here we go. Okay, so f prime of 2 is going to be 12 minus 2, writing extra work to make sure I don't make an error in the video. Okay, so our linearization of this thing is going to be f prime of a, so the value of our derivative, so that is 10. And then x minus our x1, so that is going to be the value where a is, so that's at 2. And then it's plus, oh no, it's going to be super hard and complicated. We never figured out what f of a was. Oh no, I did it out of order. Okay, that's fine. We'll just go down here. We'll figure out what f of 2 is going to be. That's just going to be 2 cubed minus 2 times 2 plus 3. Well, that apparently is 8 minus 4 plus 3. So that's 7? 7. There's our linearization. I could go through the process of simplifying that down, but I don't want to. I want to move on to part B. In part B, we want to figure out how accurate is that approximation. So we got to figure out what L of A plus 0.01 is and what F of A plus 0.01 is. So I'm going to do F first. I'm going to do F first. F of 2.1 equals 2.1 cubed minus 2.1 plus 3. So that's just, I'm going to put that in my calculator. I got 8.061. I don't feel like it's worth video time to show me typing that in my calculator. Next, we want to figure out what L of 2.1 is and see what the difference is. So if we put that in, L of 2.1 is 10 times 2.1 minus 2 plus 7. So that is, I can actually do this one. So that is 10 times a tenth plus 7, which equals 10 times a tenth is 1 plus 7. So that equals 8. So our approximation is off by 61 thousandths. So that's pretty close. There's my sentence. I don't know if I spelled thousandths right, but whatever. So yeah, it was very close. Thanks, linearization. So in this example, I want to figure out what the linearization of my function is. So I'm going to start by finding the derivative at that point. That would be the derivative of 1 over, I'm going to put a 0 for my x because I'm just want to substitute this in real quick. I would do a chain rule, but the derivative of that inside is just 1, so it doesn't do anything. So the slope of my original function at 0 is 1. I'm going to remember to figure out what the value of my function is at that point as well, so I can get that y value. So that's the ln of 0 plus 1, which is the ln of 1, which is 0. Yeah. Okay, now we're just going to plug it into my linearization. So the linearization of my function at the point 0 is going to be my slope, which is 1, and then x minus my a value, which is 0, so 0. Plus the value of the derivative at that point, which is also 0. So I probably could simplify this whole process and say my linearization is x. Let's see how accurate this linearization is. So f of 1, nope, point 1, uh, f of point 1 is the ln of 1.1. And I don't know what that is. I can't do that. So I'm going to put in my calculator. And there it is. So I couldn't do that, but I bet I can do the linearization of it. Well, it's going to be really hard. Oh no, it's point 0.1 because it's just x. So, how off are we on this linearization? How accurate is it? Well, it's just off by, well, let's see, that would be, um, I did a little thinking. It's 47 tenths, 100, 10,000s, 47 10,000. So it's very, very accurate. Well, I couldn't figure out what the ln of 1.1 is. I could use that linearization in order to figure out what the value of it is pretty accurately without a calculator. In this example, I want to figure out what the percentage error is, but we first have to figure out what our linearization is. So let's start with that. My linearization of this thing at 64 is going to be my slope, which is 1/48th, x minus our x1, so my x value that I used was 64, um, plus my y value, which is 4. I'm going to use my linearization to help me out. So that's 1/48th of 66 minus 64 plus 4. Okay, so now they want us to figure out what a percentage error. So right now we know that the cubed root of 66 is approximately 97/24. So we want to figure out what the percentage error is. And the percentage error is just like how off were you divided by what the actual value is. So that's going to require some calculator stuff to do. So we can't find out how accurate we are with this linearization, but we can use the linearization to get an estimate for things that we can't find without a calculator. So we want to do the cubed root. We want to know how far were we off. So what's the difference between these two? Divided by what our answer should have been. So the cubed root of 66. That's how you find the percentage error. So this is what I got. Mel helped me. But it is not a percentage yet because I just did that division. But then I still need to multiply it by 100 to make it actually a percentage. You know how you like multiply your score on a test by 100 to find your percent. So I was off by 0.01%. So that is very little that I am off by, not even a full percent. But it makes our answer A. That's the end of our video on linearization. I mean, look at this thing. That looks really intimidating, but it is just the like point slope form is all it is. It's just they moved this y to the other side and replaced the y's with f of stuffs. And that's all you do. So it's not big scary. It's just for babies. Just for babies. Ah.